In this video, we will practice writing absolute value functions as a piecewise defined function. The first step is to figure out the split. When do we jump from one piece to the next? And so that's going to happen when this function is equal to 0. And we're basing that off the idea that absolute value of x would have the split right at 0. And this is just a translated version of absolute value of x. So we kind of apply the same logic. So to start, we take the 3x plus 2 and ask, when would this be 0? So we can subtract the 2 from both sides and then divide by 3. And we find that when x is equal to negative 2/3, that should be where our function splits from one piece to the next. The left side piece will be for when x is smaller than negative 2/3. And we can just take the 3x plus 2 and make it negative. And the right side piece is just going to be the positive version. And again, this is all stemming from the idea of the absolute value of x function and just assuming that it's a translation. And by translation, I mean it's been shifted around. In this case, it's been moved 2 units to the left and it's been stretched vertically by 3 units. So putting this all together, we can write y as a piecewise defined function. One piece will be the negative quantity 3x plus 2. And you could write that as a negative 3x minus 2 if you so desire. You can distribute that negative. And we use this piece for values of x that are smaller than negative 2/3. And another piece would be the 3x plus 2, and we use that for the values of x that are larger than negative 2/3. Now this function happens to be continuous, and it is defined at exactly negative 2/3. So pick your favorite equation and put the equality there. So I might put the equality on the top function, but it really doesn't matter. So I might say that y is equal to the negative quantity 3x plus 2 for x values less than or equal to negative 2/3. So this is what we mean by writing an absolute value function as a piecewise defined function. And this is useful when we have to take limits or derivatives, as we will be doing for the rest of this semester.